Welcome again, everyone, to the webinar for Implant Studio. My name is Alex DeVos with the CAP training and tech support teams. Today, we're going to be going over Implant Studio implant planning and surgical guide design. So for the first case we're going to do, it is just for a single tooth-supported workflow. Implant Studio can do the edentulous workflows, but we probably won't have enough time for that today. So I'll start a new case in the Implant Studio program. If you've used Trios or 3Shape, the order form should be fairly familiar. You can just rotate your view, select the unit you plan on working on, and add whatever indication type you want on the left. So in this case, I'll add implant planning with the tooth-supported setup. And I'm also going to add anatomy so that I can do a virtual crown design to better place my implant. I'll just fill out the general information for the case to keep track of the patient info. And right now, I've got it set up as in-house so that it'll generate the output STL file on my system. But if I had 3Shape Communicate set up with this, I would also see any labs or manufacturers I could send to instead. After this, I can either proceed to Trio scanning if I have that connected to do the surface scan. Otherwise, I'll skip ahead to this import step. For implant planning, it's required to have both a surface scan, like something that came from a desktop scanner or an intraoral scanner, and a CT scan. So I'll import one of those. It allows me to import DCM, which is 3Shape's file format, or it will allow you to import STL for your surface scans. This one obviously has come from a model, so it came from one of the desktop scanners. Next, I'll import the CT scan. There are a couple configuration settings the doctors should set up on the CT program end. I have seen exceptions to most of these, but there's a specific format we want. Ideally, the CT scans should be in a DCM format and multi-slice, where there's hundreds of slices like this. And ideally, it should be in an uncompressed format. When you bring in the CT, it only lets me select one of the files, but it will grab every file that's within this folder. It just pops up with this screen letting me take a look around, make sure that this is the file that I'm interested in working with. And then just select to confirm. For this case, I don't have an upper scan to work with, but you can include an upper arch scan. The only time where I'd say that it's important to import this in is if I plan on making a temporary crown immediately before the implant's placed. Otherwise, it's okay to go without this scan and continue forward. Because I set up a virtual crown in our workflow, that's the first step it takes me to after the import. But there's an extra step it skips that we can visit to virtually extract a tooth. With this case, I don't need to since the tooth has already been extracted. But if I want to, I can just click this plus sign, draw a circle around the unit I'm interested in, and it will digitally extract that. After the line is closed, I can make any changes I want by continuing to draw. Obviously, it won't be quite as accurate as if you had waited post-extraction, but it will be able to get you a quick design ready to go. But in this case, I don't need it, so I'll get rid of that extraction. If you've used 3Shape, your design tools are going to be pretty similar, but you first have to just place the crown from an occlusal view, and then you have your normal transformation tools to rotate, reposition, and resize the unit. I won't usually spend a lot of time with this. The main thing is getting the occlusion about right, because that will give you a better idea of what direction your implant should be placed. Once you've got it roughly where it should be okay to continue next. After that, we have a couple steps that open up for cleaning up and preparing the scan data. The first of these is used for cropping out the unneeded parts of the CT scan. Because CT scans can be a fairly large file size, we want to make sure the computer's graphics card can handle it. It should always tell you in the bottom down here if the computer is able to work with it. And even though my computer says it's already fine, I am going to still crop out a little bit of the data to make sure that I don't have any slowdown later on. The idea here is I have a top, front, and side head view. I can browse back and forth in the scan data to figure out where the upper and lower edges are. So it seems like this is the tallest point in this scan, so I can drag this box a little bit lower to crop out this section, and quite a bit higher to crop out this unneeded area. And just keep browsing back and forth to confirm that I'm not accidentally cutting off anything important. Browse through my other scans to continue making changes. I see a lowest point around here, so I can crop out a bit more. And then just double check from the side view since I've already cropped out 6 directions. After you've gotten rid of the unneeded parts, you can just continue next. And it's going to have us mark a panoramic curve, which is what sets up all our later views for the following steps. This step really doesn't have to be super accurate in its placement. It just helps out because it's setting up the views later on. Starting off, I want to move around this plane, which is setting up this axial view window. Ideally, I want this to be mostly parallel with the jaw, kind of cutting through just where the teeth crest from the bone. So I'll just double check from a couple angles, adjusting my rotation, raising or lowering as needed. And then I'll focus in this axial window. It's come up with a panoramic curve automatically for me, and I can just move around any of these dots to adjust it. Ideally, I want it running through the center of the jaw or the center of all of the roots, if possible. But again, it doesn't have to be extremely exact at this stage. Once you've got that edge where you want it, we can just continue next. And now it wants us to line up that surface scan to the CT scan. It usually does an okay job with the automatic alignment. This one, it does look like it is lined up fairly well. But there are enough areas that aren't highlighted green that it makes me want to line it up myself. So to do that, I'm just going to click this little 3-point alignment tool on the left. With this, it pops up with these windows so I can see both scans separate. And it's going to have me do a 3-point alignment, just like a lot of software is used to line things up. But with the CT scan, I do have a slider that I need to adjust to change what density level that it's paying attention to. So I'll just scroll down until I start to see all this extra scatter showing up, and then scroll back up until that's removed. And now I can see all of the teeth quite a bit clearer. An extra option you have at this step is if you lock your two images together, they'll always move at the same rotation from this point forward. Just make sure your views are fairly similar before you hit that lock button. So I'll just try and find 3 points as far away from each other as possible, just so I can get the best alignment. Your points don't have to be extremely exact, because 3Shape's always going to do a little bit of extra alignment on top of the points that I've made. So now I can see the majority of my teeth are now green, so that should be aligned within a reasonable accuracy. Continuing forward, the next step is the manual alignment. It gives you the option to manually change the alignment however you want. I don't usually recommend this since it is pretty freeform. It simply involves dragging around your scan data to line up the scans. So I'm typically going to never really use that. I'll rely entirely on the 3-point alignment before I go to the confirmation step and just check that off. The next step is for marking the nerve. This step will only show up on cases where you're working on a lower jaw. If you're working on an upper jaw case, you typically want to avoid the nasal cavities like you would the nerve, but there isn't going to be a step for marking the nasal cavities on those cases. To mark the nerve, we're mainly going to be drawing points in this orthogonal or cross-section view and the tangential or parallel view. To start this off, I'm going to drag around this little crosshair to change where these two views are looking, just moving around until I see this very obvious opening here in the jaw. To get a better view of the CT scan, we can go up to the CT visibility tool. It lets us adjust a couple things about the scan data, mainly the brightness and contrast with the CT, just to help me read those nerves a little bit better. So I'm just going to start off left-clicking points right at the opening, working my way in. At this point, I want to try and find a tangential or parallel view where I can see a longer span of that nerve. I can't really see anything right now, but I can browse back and forth on the scan data by holding down Control and using the scroll wheel. And you can kind of see this beige line representing this tangential view, browsing back and forth in that axial window. So now that I've browsed around, now I can see a much clearer line for that nerve. In this case, it's lined up fairly well. I can see the entire nerve, and that's only because the panoramic curve from earlier does happen to be parallel to that. If you marked your panoramic curve at a slight angle, you may only see small segments of this line at any given time, but you'll still be able to mark the nerve. The idea is I'll just keep browsing back and forth as I draw points working my way back. In this case, I don't need to mark the frontal loop that normally is available for this nerve, but to do that, you would just browse until you see that opening. And once you've gotten to the end point of that loop, you just kind of have to have the line overlap itself as you continue back. I'll browse back to where that nerve seems to be at its widest, because that should be the center of it. And just keep working my way back. An additional option is you can adjust the thickness of this marking. by using the Shift key and the scroll wheel, just to retroactively increase the size as needed. After we've marked the nerve, and I only need to mark one in this case because I'm only working on this side, I can just continue next, and we'll get to the actual planning stage of the workflow. At this point, the first thing I have to do is go to this tooth chart in the top left and click the little plus sign on any units I added during the order form creation. It'll pop up with whatever is the last implant that you had worked with, but if you hit this arrow, you can go and browse through the full list of implants that you've downloaded. 3Shape does have a pretty large list of the implant companies in there. There is no way to manually import implant libraries, but so the manufacturers do have to reach out to 3Shape to provide that library. For this case, though, I am going to use a Zimmer for the example. Once you've chosen the brand, you can sort through the different interfaces that they have available. Choose between different groups, and then choose whichever size and length that you plan on working with. So for this case, I think I'll start off with a 4.7, but you can modify it after the fact as well. Because I did do the crown design earlier, it's automatically placed the implant so it's centered underneath that occlusion. But let's say I had done this without that crown. The placement would just be slightly different. If you're placing the implant without the crown, you first have to drag along the slider till you can see that your crosshair is crossing the area you plan on working in. So I can see the blue one is running right through the middle, so I'll place this in this blue window. I'd start off just by clicking once to set the position, and then clicking a second time to determine the angle. And from that point forward, it would be the same as if I had left it at the original placement. To start adjusting this, I'm going to maximize this window so we can see it a little clearer. We can see a lot of different lines from all the different objects we've loaded in. The green squiggly line is the actual implant itself, and the green line just outside that is a safety zone. So it's just making sure that it's about 1.5 millimeters away from important objects to the sides and 2 millimeters at the tip. We have the beige line, which is our surface scan. So this is showing me theoretically, at least roughly, where the gingiva is. Right now it's yellow, but sometimes it'll show up as a darker gray. This is trying to show me the cross-section of the sleeve that's currently selected. And the other gray border is a cross-section of the crown I designed. So I can simply left-click and drag around the implant wherever I want, using the red slider to rotate it. And even without going back to the implant menu, I can use this green slider to tell which length I chose and switch between the different lengths that I have available for this implant. And if I do cross the nerve with that safety zone, it will turn red and it would not allow me to proceed forward with the next button. If you do need to override that safety zone, that is allowed, but it's not recommended. You would go to this button up here to set your own custom safety zone, which will allow you to almost completely eliminate it. But in general, 1.5 millimeters of distance to the sides and 2 millimeters for the tip should be about as close as you want to get to other objects. If it did turn out that this was an implant that I planned on using, I can pull up that menu again simply by clicking this manufacturer menu and browse and choose from any of my choices. Now that it seems to be at an okay position from this 90-degree view, I can just toggle to this 0-degree, more parallel view to try and get it lined up from that angle. And I can just keep switching between them to place it. You can also adjust the placement in the 3D window. It's just not quite as exact since I'm not able to read the CT at the same time when I'm making these movements. One other tool that they've added in one of the more recent 2017 versions is this bone density measurement. If you toggle that slider on, it lets you take a look at what level of density each part of your implant is engaging with. And it shows you on this chart the kind of average of what everything's engaging with. And you can see what each of those colors count as in Hounsfield units. In addition to looking here, there is going to be a report generated at the end of the process, and it will include these measurements as well. After you think you've got the implant just about where you want it, you would then want to focus on the sleeve that you're working with. And you can go and make that choice under this sleeve menu up here. Just like the implants, you can browse up and see all the different manufacturers available. And the only manufacturers producing sleeves compatible with this Zimmer implant will show up on this list. If I were to choose a different implant like Straumann or BioHorizon, the sleeve list will change depending on which implant I chose. Right now, the majority of the sleeves out there seem to be being made by either Rowe or Stecco. And this has a couple examples for the different styles. Normally, you're going to want to use a fully guided sleeve most of the time. That's the main purpose of creating a surgical guide, is so that it can be guided for every aspect. With these types of sleeves, you may be limited with what heights you can position at. You can only usually go to very specific heights based on the drill kit. But if I were to use something else like a pilot sleeve, it'll allow me to change to any height between a minimum and maximum. So with pilot sleeves, it's only meant for that initial pilot drill where the position is controlled by the guide, but the depth will be controlled by the surgeon. It's similar for the universal style sleeves. They'll let me adjust to any height between the min and max. But in addition to that pilot drill, you can also put inserts in to continue up to larger and larger diameters. But for most of the time, you're going to want to go with fully guided, at least if you have enough space. So we can see right now it's gray because the unit is not crossing the surface scan. But if I do have the sleeve too low where it's crossing the scan, it turns yellow. Just like when the implant will turn red when crossing the nerve, it turns yellow as a warning. But unlike that, it will still allow me to proceed forward even though it's crossing the scan. The reason for that is even though it's yellow and crossing the scan data, potentially the surgeon might be able to make a flap in the tissue to get that temporarily out of the way. But I still need to go and double check that to make sure I'm not crossing the bone where that really wouldn't be possible. But because I do have additional height options available, I'll just raise that up a little bit. Additionally, one other option that I can't use with this case, just because I'm working on only a single unit, is this grouping button up at the left. This grouping button will allow you to force multiple implants to remain parallel. It's rare that you'll have a position that works for every single implant you're working on, but if you can find it, it at least saves you from using certain non-engaging parts. But let's say we're happy with the position. I'll continue onward. Continuing next, it gets to the surgical guide steps. So at this point, I first want to focus on this cylinder that's around the sleeve. This is going to be in the printed surgical guide material. You can adjust this with green sliders to adjust the width and length. Because I'm going to have support on either side of this unit, I can raise this up off the tissue, leaving space for blood and saliva to evacuate and making it a little bit easier just for the surgeon to see what's going on. If I were working on a sleeve or an implant on the opposite side where I could only have support on this one tooth continuing forward, it'd probably be better for me to have this go all the way down to the tissue in a situation like that. But I'll raise this up for this case. In terms of the width, you generally want this to be just barely wide enough to reach into the adjacent teeth that it's next to. The next thing that I want to focus on is the insertion direction for this guide. This insertion or seating path is just for the guide. It's not affecting the implant placement. And we can see at the current angle, the darker brown areas are considered undercut. It seems to be okay. I've got the buccal side mostly non-undercut, but the lingual side is still pretty covered. To change this, I'm just going to get a top-down view where I think would be the best seating path for this guide. Let's say I'm just doing a guide on this quadrant. I'll just adjust my view and then use this view direction placement tool to adjust that. Just adjust the angle to wherever I happen to be looking from at that moment. After placing that direction, I can now mark any remaining surface area for the guide just by clicking this plus sign. So I'm going to add one of those pieces just to this one tooth, just working my way around the unit. It is okay to cross into the undercut area. The software knows to block out these undercuts to make sure that the seating is still viable. And once you've closed the line, you can continue drawing to make changes however you want. For the next side, I'll just click that plus sign button again. Just start drawing the same way. The surgical guide design can be a little bit sensitive to the scan data. You do want to make sure that the scans you're taking or receiving are fairly clean. For example, this case has a tiny little triangle point right here that I know is giving me issues in the past. But you'll just want to try and avoid any jagged edges or holes in the scan data that aren't going to be as accurate anyways. So I'll just continue along, bring this a little bit lower to make sure it's connected securely to the rest of the guide, and then continue and make changes once the line is closed. There are a couple extra options we have with this step that you don't need to use for every case. This button here for orientation marks, we won't see anything right away, but it's going to add little notches to the 0 and 180-degree points around the implant, so the surgeon has a better idea of what angle he's supposed to start at. You can also add these glue channels, which are going to create a hole on each side of this. The idea with this tool is you're able to put the sleeve in first before you glue it in place by feeding glue through these holes. Unfortunately, at the moment, you can't change the width of these glue channels. So right now they seem to be a little bit too narrow for most of the glues that you use. This next button will let me revisit my sleeve choice. I can still change whichever sleeve that I chose from earlier at this point. And if I were to make this change, that will reflect at the previous step if I continue and go back. So you can make the sleeve choice at this step or the previous step at will, and it always updates properly. Our last set of options is choosing which printer that we're going to produce this in. They do have a good number of the printers on the market in here. And if they don't have the printer you use, just contact that manufacturer to figure out which settings you should be using down here. We have the overall thickness of the material and the spacer that it's putting between the guide and the teeth. Most of the printers right now don't allow you to use this retention amount, which allows the guide to go into the undercut areas, meaning that it would have to snap into place. Right now, most of the guide materials are fairly brittle, so they can't really handle that retention amount most of the time. And then offset from sleeve is just the spacer in between the guide and the surgical guide sleeve here, just to make sure you have enough space for whatever glue or adhesive you're using. So once I've got all these settings where I want, I'll just hit the preview button to see what this looks like. It may take a second to load if I had just been making changes. So I can see where anywhere close to our working area, it knows to cut away. And it's even making a window here so I can better tell that it's fully seated. As I continue next to the bars and windows step, I can add more support areas or window openings. So I'll just make that choice to add a view and window. And let's turn our guide just slightly off so I can see the teeth a little clearer. Just like placing that crown from earlier, I'm just going to start by clicking from an occlusal view to place it, and then I can adjust the position and size as needed. And you can add as many or as few openings as you want. Additionally, you can add extra bars for support. Most of the time, people will use these support bars to run between the two posterior teeth if I add a full arch surgical guide. I usually am okay with that on an upper arch, but you're usually kind of limited by the tongue for lower arch cases. An additional use for this would be to add some extra support to the lingual side of this guide. Right now I can see on this mesial side, it's not really held on by a lot of material in that section. I can go to one of these support bar types and just run it through the length of the guide. Right now that's running through it at a kind of awkward position and size, but I can continue resizing and changing it as needed. Pulling it in a little bit to hide the rougher edges. But once you've got that where you want, you can hit the preview button, and even though this is crossing through my working area, the software knows to cut away any of those sections. So I haven't wound up adding much in this case, but I did add a little bit of extra support there. Afterwards, the last remaining step where I can make changes to this design is this ID tag step. It's not required to use this, but you can hit the plus sign and type in whatever you need for the case. Adjust your size as needed, and if you want it to be an engraving, you'd invert the ID tag before you click and place the unit. Afterwards, I can hit preview to see what that looks like. The last remaining steps of the guide are all about approving and generating our outputs. So as I continue next, it has our approval terms, and it'll let me pull up a surgical report to send to the surgeon or doctor. You'd open up this report once it's ready to generate. And let me just adjust my settings. I believe it may have popped up off screen. Okay, so it pops up with a report like this, where it shows you a brief preview of what units you're working with, what parts, and it would have a separate page for each implant I'm placing that shows me where everything is and what densities it's engaging with. Once I approve the planning, after I get that signed and received back, I'll confirm. And what it's going to do is it's going to lock everything up to that step. Once you get the approval, everything about the implant planning becomes view only. And the same thing happens once I approve the surgical guide. Once I click that, the guide step becomes view only as well. Right now, at least, there is a way to get around this by making a copy of the case, and it does unlock the copy. Just make sure that after making changes, you get a new report signed off on. Afterwards, I can continue next. It'll load for a little bit and let me open the folder where that output has been saved. So we can see it's still showing that surgical report. I've got my lower jaw scan that I could load into 3Shape to do a temporary design. I've got a surgical guide STL that I can send to my printer. And it also generates an additional drilling protocol that gives me details on what drill lengths I'm supposed to be using. This offset plus the length here gives me the drill that I'm going to be using. And that is it for the main surgical guide steps, at least for the tooth-supported workflow. At this point, I'm going to open it up to questions. I'll start off with anyone who's posted anything so far, but we'll stay in for at least 15 minutes to go over those questions. I just got a question on bone reduction. Unfortunately, Implant Studio currently doesn't support any bone reduction guides. It is something that we get asked a lot, and we do pass that on to 3Shape. I've never received any exact confirmation, but it's something that it does seem like they're interested in adding. I just don't have any estimate on when or if that would happen. Right now, I don't have the pricing for the Implant Studio software. You'd want to reach out to your Henry Schein rep to get a quote. I have another question about the legal requirements. This software has that report that it generates at the end, and it's expected for a dental technician to give that off to the doctor or the surgeon to sign off on the implant placement. Most labs will come up with a waiver on top of that to make sure that it's been waived to the doctor's responsibility for confirming the placement. That's what kind of allows labs to do this planning process instead of just going to the doctors. Right now, the guides are FDA compliant based on whichever printed material you're working with. The important thing when it comes to FDA compliance is making sure that you're not just recording your manufacturer's FDA clearances, you need to record your own process for intaking cases, designing it, generating your files, printing. All of that has to be recorded down in your own personal documentation to make sure that you are FDA compliant. As long as you're recording everything and everything's being done consistently, that should be enough for the FDA. I got a question about the printer preferences. When I was choosing the printers earlier on, those are just the default printer settings that come with 3Shape. All of those changed, those default settings like thicknesses and retention spacers. All of that can be modified. So if you do have a printer that's not on 3Shape's list, just because those manufacturers reached out to 3Shape, you can still modify those settings as needed. You would just have to find out from your printer manufacturer what that material is supposed to be in terms of thickness and spacer. I have a question about more about pricing in a way. 3Shape functions off of a subscription system. Right now, they won't allow you to pay as you go for each case. You do have to get the full license, which is usually a yearly subscription for Implant Studio. I got a question about a screw retain temporary. Right now, it does allow you to take a file into your normal 3Shape designer program, and that will have the implant placement from before. In this open folder where it's generated, it's created this DCM file, which has my surface scan along with some implant coordinates. So we need to pop that up again. Interesting. GoToWebinar doesn't seem to like my 3D viewer. That's okay. But this file is what it outputs, and I just have to import that into a dental system case, and it will have all the implant coordinates that I need to design the temporary crown. 3Shape technically doesn't limit this to just temporary crowns, however, but they do only recommend temporaries. That 3Shape doesn't support producing the final restoration before the healing has happened. Let's see. Yep. I have a question about the software in general. This Implant Studio program is part of a program 3Shape calls Dental Desktop. This also lets you work with a trio scanner and do some basic crown and bridge work, and it will allow you to send to certain milling machines. Right now, the majority of 3Shape's design is done outside of this Dental Desktop program, but it seems like as we continue forward, 3Shape is moving more and more applications into this Dental Desktop program. But on top of that, you would have to get additional licensing for each type of design that you plan on doing. In terms of the software requirements, I'll have to double check. There's a document that's publicly available on 3Shape's website that just gives the computer requirements. For implant planning, you do typically have to have a pretty good graphics card. That's the main limitation, is just because rendering the CT scans can be fairly intensive. But most of the general laptops and desktop computers should be okay, but you would just have to double check what graphics card it's utilizing. I got a question about the production of the surgical guides. It is possible to mill out these guides. Right now, not a lot of the milling companies have strategies specifically for surgical guides, and that's the reason why it didn't have any settings for that as part of this workflow. The main reason is most nesting programs utilize round-tipped milling burrs, which aren't able to get at a lot of the sharper corners that you see for the sleeve. You'd normally need to have a flat edge milling burr and strategies to go along with that to mill it out. But I do know a couple labs that are producing it that way. Additionally, about the surgical guide design, the only real tools available for changing this design is with the addition of bars or cutout of windows. The software won't allow you to sculpt on the surgical guide because allowing something like that may cause other violations like minimum thickness and things like that. In terms of 3Shape's FDA compliance, they did have to limit a little bit some of the controls in order to get that approved. I had a question about 3Shape software in general in terms of its capabilities. And yes, 3Shape with Implant Studio you can use to plan the implant and produce the guide. You would have to use 3Shape's general dental system program to create printed models, abutment designs, or screw-retained crown designs. But that's all capable within 3Shape's various software. In terms of FDA compliance, I'd have to look up the fine print on it. Right now, I don't believe labs are registering with the FDA to create this. It's mainly just confirming that you're keeping a good record of everything in your process if the FDA does investigate, which right now it's still being kept as a kind of gray area. We don't have the exact details on who they're enforcing this with. Just make sure that you're working with a printer material that's already cleared for intraoral use, and you're working with your process well recorded. I have a question about the approval for 3Shape. It can technically be modified after the approval, but only by making a copy of the case. Right now, this case, if I go back, I can go and view my implant position and where it's placed, but I can't really make any changes at this point because it's view only. If I were to go back outside of the case, I can right-click and copy it. And for the copy, I'm able to revisit and make any changes. Oh, whoops, I think I opened that original one again. So for this copy I made, I'm able to make any adjustments I want once it loads back in. Right now, I don't know if that's by design or not. There were older versions of Implant Studio where even a copy of the case would not allow you to make changes. So the only other way to confirm that you can always go back in and adjust it is make a copy of the case before you confirm that approval. As long as you do that, even once you approve it, you still have the copy that you can go back to. For the surgical guides, it is required to have both the CT scan and the surface scan. There are ways in 3Shape to make other types of placement jigs, but it's technically not supported by the printer materials or the FDA to do any surgical guides without CT placement. In terms of other training events, we do offer a 3Shape dental system training. We have an advanced classroom that we do about every other month, either at our office near Boston or near Denver. Um, but other than that, you can reach out to your reseller. They usually have on-demand phone support, and I know we generally will offer additional training over the phone if we set up a time. Depending on it, there may be a different cost associated with it. Unfortunately, I'm from the U.S. side of Henry Schein, so I don't have a lot of info on what events they offer on the Canadian side. Um, I'll have to double check, but I'm pretty sure right now we don't have any events in Canada, but I'll double check and see if there's anything that we can do, because I know we have a couple offices up near Montreal. Oh, I got another question. Again, bone reduction is something that we get a lot of questions on. Right now, bone reduction isn't available with the implant planning software. It's something I've definitely recorded to 3Shape several times, and they have let me know that it's something they're interested in doing, but I don't have any estimate on when or if it would be added. I have a question on the edentulous workflow. For non-tooth supported guides, I do have a video that will be coming out also on that part of the workflow. I don't believe it's up quite yet, but it's already made, so it should be on its way. That would also be posted to our YouTube page and website once it's ready. Um, I think 3Shape on 3Shape's YouTube page, they already have a video on the edentulous workflow. Um, I don't believe there's any plans right now to create the webinar for that workflow, but it may be in the future. In terms of how many implants each guide is recommended to support, it varies. It's mainly based on what printer material you're working with. You'd want to contact your printer manufacturer to determine what's the maximum amount of implants that it's able to support for the placement. And yes, you can design a case with multiple implants involved. Even on tooth supported, I can add as many implants as I want if I have the space for them. And for edentulous cases, I can add as many implants as required. Okay, I think that's about it for the webinar for today. Again, if you have further questions, reach out to your reseller. If you don't have Implant Studio or 3Shape already, you can reach to our Henry Schein sales reps, and they can get you a quote and potentially a demo of the software as well. If anyone else has any questions, you can reach us at our tech support team. The tech support email is captechsupport@henryschein.com. Otherwise, just give us a call if you have any other questions. Have a good one. Bye-bye.